Allow me to introduce myself. My name is Alex Butcher. I'm the Director of Learning for Science at Chobham Academy. If you're watching this video, then more than likely you'll be joining us in September. I'm very glad that you've chosen Chobham Academy. I'm sure that we'll work very hard to help you achieve your dreams. What follows is some introductory material regarding my science staff, including my subject lead for chemistry, Yusuf Mohammed, my subject lead for biology, Noreen Monarch, and also my physics subject lead, George Rodriguez. Enjoy the video. Before we get into the details of the science A-levels on offer at Chobham, I'd like to share with you a statement about the teachers. The science team at Chobham really cares about their students and works tirelessly to guide and inspire them through the A-level courses. Our science teachers provide a curriculum diet that builds their science capital and develops skills that are relevant and useful in all walks of life, including outside of academia. Here are a few things to expect when studying A-level science at Chobham. We have high aspirations for all of our students regardless of their intended destinations, be it further science studies at university, an apprenticeship, or straight into a career. We will help you to realise and develop your aspirations for these destinations. We also have excellent practical facilities and a dedicated staff to support you along your journey the whole way. The Science Department at Chobham Academy offers A-level biology, chemistry and physics. The exam board for all of these is AQA. If you have any course specific questions, please email the relevant subject leaders. Their details are on this slide.
Hello and welcome to this introductory A-level physics presentation. I'm Mr. Rodriguez, the subject lead for physics at Chobham Academy, and this PowerPoint will explain the course specification, how the content is assessed in terms of the exams and coursework, all in accordance with the AQA examination board that we follow. The first thing to note is that this course is intensive and requires you therefore to be very independent with your learning. You will need to ensure that you are reading around the subject, making notes and refining them, and working through past paper questions continuously. To make organisation of all these materials easier, you are required to invest in a folder just as the one shown in the slide. So not one that's ring bound, one that opens like this with different plastic wallets. You will receive 2 exercise books per topic. The reason for this is one will be for writing notes and the other one will be for completing questions that are set in class. These books will be kept in the folder in addition to your lab book and any exam questions that have been printed. This will be therefore your evidence that you are completing work properly and will be checked by your teachers at regular intervals. This next slide will cover assessment. So paper 1 covers sections 1 to 6.1 and these are all covered in year 12. Paper 2 covers from section 6.2 to 8, but it does assume all knowledge from the paper 1 content. Paper 3 is slightly different. There's a section A and a section B. Section A focuses on practical skills from the required practicals that you will undertake during years 12 and 13. So this paper will assess how you can analyse data, how you look at uncertainties, whether you can draw a line of best fit and work out their gradient, whether you can describe experiments, and how to reduce uncertainties. Section B assesses the optional topic. We will likely do turning points. For all of these, papers 1, 2 and 3, there are a lot of past papers available. So, each paper is 2 hours and each paper has a total marks of 85. So you will have more than a minute per mark, which means that you can really think about your answers in the test. Each one of these papers is worth a third of the A-level. So, in papers 1 and 2, you have 60 marks for the short and long answer questions, and these can be made up of 6 marker questions and some even unstructured questions that require a lot of calculation. So they won't give you any prompts like in GCSE, but you will need to construct a logical calculation of several calculations to get the answer. And then you will have 25 marks of multiple choice. For paper 3, it's slightly different to paper 1 and 2. You will have 45 minutes of the short and long answer questions with no multiple choice, and this will be on the data analysis. And you'll also have 35 marks of short and long answer questions on the optional topic as well. In this slide, this breaks down which sections I was referring to in the previous slide. So as you can see, in the core content, paper 1 will cover sections 1 to 6.1, so that's measurements and their errors, particles and radiations, etc., all the way down to 6, which is further mechanics and thermal physics, section 6.1. That's the paper 1. Paper 2 will cover 6.2 to 8, however, it can still assess all of 1 to 6.1 as well. Paper 3 will be on the practical side and the data analysis questions, but section B will be focusing on turning points most likely. This slide will focus on the required practicals. So there are 12 required practicals in total. Practicals 1 to 6 will be undertaken in year 12, and the rest, 7 to 12, will be undertaken in year 13. You'll receive a practical booklet, a lab book, which you'll have to write write-ups for the experiments, which will include the methods, and you'll begin to develop skills that will be used for section A of paper 3. Whilst carrying out your practicals, your teacher will assess your practical skills against the Common Practical Assessment Criteria, commonly known as the CPAC. So over the 2 years, we will be observing to see if you can demonstrate a number of competencies that the Department for Education have published, and you will either receive a pass or a fail. This does not go towards your final grade, so there is no contribution to your final grade. However, questions in paper 3 do assess some of the requirements that will appear in your examinations. Much like chemistry and biology, you will receive lab books. You will need to make sure that the work within these is entirely your own, and make sure that the quality of the presentation within them is extremely high. This will make it easy for us to assess you and pass you for the CPAC. You'll receive a CPAC sheet where we will record which of the CPACs you have evidence for. In this slide, I just want to talk through the transition materials that are available to you on MS Teams and that are mandatory to be completed before September. What I'd like you to do is look through the list of resources in the AQA Transition Guide and compile your own notes in preparation for the course. In addition to the resources recommended in this guide, there is a textbook available in MS Teams, the one that you will need for September, as a PDF version, a link to a revision guide from CGP, and websites such as Physics and Maths Tutor, Khan Academy, Science Shorts, and Seneca Learning. I would also like you to complete the activities within the AQA Transition Guide to ensure that your math skills are adequate to begin the A-level physics course. Next, I would like you to complete the pre-knowledge topics section in the A-level physics transition pack 2020 to 2021 to ensure that your physics knowledge is adequate to begin the A-level course. You can find the mark scheme for these questions at the end of the document. If any of the topics that you are meeting in the AQA Transition Guide, so that's for the math skills, or the A-level physics transition pack 2020 to 21 are too hard or you are struggling with, I will implore you to have a look at the resources I've just mentioned to get yourself up to scratch ready for September so we can hit the ground running. The final thing I would like you to do is familiarise yourself with the AQA A-level specification. That way you will know everything that is likely to come up in the exam, it's in comprehensive, and you will know what you will be taught over the coming 2 years. So it's vital that you do all of these actions I've asked so that you'll be in the best possible position for September. Okay, if you're not in that position, it's going to be extremely difficult to catch up, because as I referred to before, it's a very intensive course that requires a lot of independence. The first topic that we will cover as you come in September will be particles and radiation. So as an extension, if you feel like you're in a good enough place after going through these materials, then please have a look at this topic, particles and radiation, and begin making notes, and maybe having a look at some exam questions to gain a good head start.